excited to have you back here again. This pretty much will conclude our notes that we'll be taking. This will be over magnetic force. That is the force that is created by the current and the magnetic field. Objectives, things that we want to learn. Given the force and the charge in a magnetic field determines the strength of the magnetic field. So we're going to determine the strength of the magnetic field. We're going to use the right-hand rule to find the direction of a force on a charge moving through a magnetic field. And then we're going to also be able to determine the magnitude and direction of a force on a wire carrying current and a magnetic field. So these should be the three things that you should be able to do when we're done here. The first thing here is our equation for force on an object, a magnetic object, and a magnetic field. Things I want you to understand is that B, which is something we'll use quite often, stands for the magnetic field. Sometimes is referred to as the flux, magnetic flux. I is the current, and L is the part here at the very end, is the length of the wire. The units are in Teslas. So the magnetic force is B times I times L. The stronger the magnetic field, the more force. The stronger the current, the more force. The longer you make that wire going through that magnetic field, the stronger the force. So those are the things that you could do to increase the strength of the force. Right-hand rule. What I want you to understand is that all of these things start acting perpendicularly to each other. And we're going to start to include three different directions here. When it comes to the force, what's going to happen is our fingers are going to represent the velocity. And we're then going to curl them with the magnetic field. Your thumb is going to tell you the resultant force. And this is with your right hand. So you'll start by pointing your fingers. Let's say you take your hand and the velocity is away from you. So your fingers will get pointed away from you. If you said the magnetic field is then acting down, well, then I would take my fingers and point them down, and my thumb points to the left. So the magnetic force would be forcing this wire to the left. Contrary to this, if I said, okay, the velocity is acting away from me, and now I'm saying the magnetic field is acting up, I'd have to turn my hand over, and now my fingers, my arm is pointing away from me, but my fingers are now pointing up, and the resultant force would be pointing to the right from you. So if you can imagine yourself sitting there, you might want to pause this and replay the last minute and visualize that yourself right there in front of you. All right, here's our first problem. We've got this wire. It's 36 meters long. It's carrying a current of 22 amps from east to west. The magnetic force on the wire due to the Earth's magnetic field is downward, so our thumb would be pointing down, and has a magnitude of 4 times 10 to the negative second newtons. That's the force. Find the magnitude and direction of the magnetic field at this location. Well, what we have here is, here's our list of this given information. All right. The current, the first thing I'm going to do is I'm going to try to find the direction. All right. The current is going east to west. So the first thing I'm going to do here is my current is going to go, I'm going to draw a picture of my current going east to west. So my current is going in this direction. So that's the way my fingers are initially pointing. It then tells me that the force on the Earth's magnetic field is down. So for me to be able to have that force going down, I'd have to have my thumb pointing down. So there's the current. Here is the force. It's going down. So think about your hand here. Your hand would have to be, here's my fingers, and then my thumb is pointing down. Well, you've got, essentially, if your hand were to be there, then you wouldn't have the palm of your hand you'd be seeing the back of your hand, and I'm going to put B there for back of your hand, which tells me now if I were to wrap my fingers, the fingers would be pointing away from us. They'd be going right now into my PowerPoint. So that means that the field, right, interestingly enough, I chose B there already. I'm going to choose the B. The field would have to be going into the PowerPoint. So I've found the direction. All right, the magnetic field has to go in. Again, my fingers are pointing in the direction of the current. My thumb is pointing down because of the force, and I'd be seeing the back of my hand right here, right, where your teacher would have stamped it when you were a little kid. You would have said, oh, do I get a star stamp? Yes. All right, so you'd get a stamp right here where the B is. And then if I wrap my fingers, it tells me that the field is going into the PowerPoint, which means we'll see the tail of that. At any rate, so the rest of this becomes fairly simple. F equals I, L, B, or BIL, doesn't really matter how you put it up here. The force they give us to be 4.0 times 10 to the negative second equals the current, which is 22 amps. The length is 36 meters. Solve for B. B in this case turns out to be 0.00005 Teslas. Or we would write this as 5 times 10 to the negative fifth Teslas is what B is. Okay, here's another example. We've got a 123 meter long wire. It's carrying a current of 2.9 amps. This time the current's going west to east. And the magnetic force from the wire due to the Earth's magnetic field is still downward towards the Earth. And it has a magnitude of 3.2 times 10 to the negative first newtons. Find the magnitude and direction of the magnetic field at this location. So what I want you to do is go ahead and pause this, and draw a picture of it, and see if you can't find both the magnitude and the direction in this case. Okay, what I've done up here at the top is I've drawn in my hand, and for my hand to be going to the right like that or to the east, I'd have to be looking at my palm. So what I've tried to draw there is my palm in the lines that you'd see in my palm. My thumb's pointing down for the force, and now if the Earth is down, they tell us that the Earth is down here. All right, so this is the Earth. It's pointing down towards the Earth, and maybe we can move it over a little bit, but at any rate, east is to the right, west is to the left, then north, all right, north would have to be going into the PowerPoint, and I didn't talk about this in the last problem. South would be coming out of the PowerPoint. Well, if I wrap my fingers, they're going to be coming out of the PowerPoint right now, which means the magnetic field would be coming out or be coming to the south. And we can talk more about that if you have questions. I'm sure you're going to have some questions about that. At any rate, this is our notes over force. I look forward to seeing you tomorrow, and I'll catch you on the flip side.